Good morning guys, and welcome to today's worked exam answer video. Today I am having a look at a required practical question because I imagine those of you in year 13 will be having mocks soon if you haven't already, and of course the summer exams are looming ever closer, and those of you who are in year 12 who will have also have covered, I presume, the practical and theory relating to this question will also have your year 12 end of year exams coming up soon. I know some of my students have theirs quite soon, some not quite so soon, but I've chosen a practical question because in my experience the required practicals can be forgotten about or ignored, or perhaps not intentionally ignored, but it's not always clear how important knowing the practicals is for answering some of the exam questions. So it's not just a case of you go and you do the practicals and you gain your competency skills. We need to understand for each practical what we're doing, why we're doing it, how we do it, and then be able to do kind of any associated calculations. So with titrations, which is what this question is on, you may be asked to perform a back titration calculation, and then you might get 1 or 2 marks afterwards that say, why are we going to do this and not this, or what might the problem be with this? And that's been fairly common, but this question is thinking solely about the what we're using, why we're using it, how we're doing the method and why we do it that way. So I thought this was a really good one to have a look at, because it might be that you look at this and go, oh no, I would have had no idea how to answer this. If that is you, then please don't panic, because there's still plenty of time, but you do need to start addressing the required practicals. If you're feeling semi-confident with this, that's fantastic, you're on the right track. And if you have already thought about the required practicals and you can answer this confidently, then humongous well done to you guys. But whichever stage you're at, here's the question, I'll work through it, and if there's any other required practical questions that you would like me to have a go at, as always, please just let me know. Or if there's any advice that anyone needs about how to revise for the practicals or what sort of things might come up, again, please do not hesitate to make contact. So we're thinking about the technique for our titration, and it says at the top that the correct technique can improve the accuracy of a titration. So all of these questions up until part D are thinking about accuracy, and then we've got a reliability question towards the end. So first of all, it says state why it is important to fill the space below the tap in the burette with solution A, whatever that might be, before beginning an accurate titration. Now, you might not be familiar with what the question is even referring to, and I would attempt to draw a diagram. I will, but brace yourselves, it's not going to be very good. So you've got your burette, which kind of then comes together like this, and then there'll be a tap here like that. Told you, not an artist in any way, shape or form. The part that this question is referring to is this bit here. I'll colour in light blue. So underneath the tap in the bit of glassware before the burette ends, why it's important to fill that space before you start the titration. And with some of these questions, it might be that you can think logically without kind of really knowing the reason, but think about visualizing yourself doing the practical and try and spot what the problem with that might be. So if I open the tap and the underneath the tap is already full, then that volume will go into the conical flask before sort of anything from the burette comes out. If we were not to fill that up, we would open the tap, and the first thing that would happen is that space below the tap would get filled and the amount in the burette would drop down a little bit. So even though none of the solution had actually left the burette yet, the initial volume reading that we took would have changed, even though we haven't actually used any of that solution. And that means that the end volume is going to be bigger than it should be, and therefore our titers are going to be bigger than they should be, because solution won't have left the burette, but we will have seen a drop in the meniscus at the top, towards the top of the burette. So we have to have that full, because then when we open the tap, immediately it all starts to drain out, and then when you close the tap, solution will be held in that space under the tap as well. So if you don't have that full beforehand, but it will be full at the end, then that inconsistency is going to affect our titers. So for this question, I am going to write this it's a tricky one to try and word. This will prevent the okay. Just had to think about that one a little bit for myself. So I've written, this will prevent the level in the burette dropping before any solution leaves the burette, which would give us larger and inaccurate end volume readings and titers. So having had a look at the mark scheme for this prior to filming this video, they don't want you to be vague in saying, oh, the end reading would be affected, or the size of the titer would be different, or, you know, things like that. They want you to say specifically whether the titers would be bigger or smaller, or whether the end volume readings would be smaller or larger, that kind of idea. And that's not just the case here, that applies for all sorts of practical questions across a number of required practicals. Try and be as specific to the practical you're talking about as you can. Don't just say, for example, oh, it would affect the temperature change. How? What's going to happen to the temperature change? Is it that the final temperature is going to be higher or lower, etc.? So that's what I've done here. Okay, slightly easier question, this one. Suggest one reason why a conical flask size 250 centimeters cubed is preferred to a 250 centimeter cubed beaker. Now again, even if you weren't sure about this particular question, you can possibly work it out from the shapes of the apparatus. So there's my conical flask, there's my beaker. Again, not an artist, but they look vaguely what they should look like. One of the things that we should be doing when we're emptying the burette into the conical flask, which is what we do use, is we should be swirling the conical flask with our other hand. So one hand is used to operate the tap on the burette so that we can stop it and then open it so the solution comes out more slowly. Kind of keep opening it and closing it to release drop by drop towards the end. If we're then using our other hand for swirling, with a beaker, there would be the potential for the liquid to splash out, or a much greater likelihood that some of the solution in the beaker will splash out. whereas in a conical flask, because it's got the narrow neck, we are less likely to get splashing of the solution from inside out. And not only is that potentially a health and safety issue, from an accuracy of our titration point of view, that will change the volume that needs to be added from the burette to the conical flask to get neutralisation, and therefore we're going to get inaccurate values in any calculations that we do. So just one reason why the conical flask is preferred. So I'm going to put the narrow neck of a conical flask helps to prevent any solution splashing out when the flask is swirled. Okay. Then it says, during a titration, a chemist rinsed the inside of the conical flask with deionized water. The water used for rinsing remained in the conical flask. So this has been asked before, and a couple of people have confused this with kind of rinsing the conical flask out at the end of the titration. We're thinking about doing this during the titration, and we tend to do this as we get closer and closer to the end point. So for example, if we're using phenolphthalein indicator, that's in our conical flask with an alkali, that will initially start that lovely magenta pink colour, and that pink will get paler and paler, and then we would be looking for it to go colourless. So as you start to get towards pale pink, you may stop the titration for a second, rinse down the inside of your conical flask with deionized water, and then carry on. And this question is basically asking us why that particular rinsing can improve the accuracy of the end point. Now again, I'm not going to draw a diagram for this, but if we imagine having our burette inside our conical flask and us obviously swirling the conical flask every time we add another drop from the burette, initially we will be adding quite a lot of solution from the burette, sort of in one fairly sizable stream, but then as we get towards the end point we would be doing it drop by drop. What if one of those drops ended up sat on the side of the conical flask up here in the neck and didn't actually go down into the main part of the conical flask where the solution is? Well, that would again mean that we've accounted for that drop going into the sort of solution that's in the conical flask in terms of it's come out of the burette and the reading on the burette will change, but it hasn't actually gone into the solution, so it's not accounted for in terms of the colour of the indicator. So when we rinse down the sides, we're ensuring that any of the solution A in the burette is actually in the mixture in the bottom, because if it isn't, then we've accounted for it but not technically used it, if that makes sense. So it's to ensure that all of the solution A from the burette is in the mixture within the conical flask and not stuck on the sides. Okay, now I'm going to use solution A because that's what they said is going to be in the burette. We don't know what solution A is, whether it's an acid or an alkali, so just go with what they've used. So some solution A may be stuck on the sides of the conical flask. And rinsing will ensure that this is wash down into the solution in the bottom of the conical flask. Okay, so that's why we do it. Then it's asking us to explain why the water used for rinsing has no effect on the accuracy of the titer. And this is where, again, students can get a little bit confused, because when we think about rinsing pieces of apparatus prior to doing a titration, we would never want to use water, because that would dilute the concentration of what we then put into either the burette or the pipette, and the idea is we're supposed to know the concentrations of those. One of them may be a standard solution, so it's a solution of known concentration where you've dissolved a very accurate mass of solid into water, and if we then dilute it, then we have absolutely no idea what the concentration is going to be anymore, hence making our results inaccurate. This has no effect because the number of moles of alkali in the conical flask, if that's what's in there, and the number of moles that we've added from the burette isn't changed by adding water to it. It would change the concentration because the volume's changing, but it's not going to change the number of moles. And when it comes to then doing our calculations afterwards, it's always numbers of moles that we want to work out. So dilution never affects the number of moles, and that's the sort of principle that we can use when we're doing dilution calculations, and it's the reason why we can rinse here. So the water added will not affect the number of moles of each solution in the conical flask. So again, there's no downside to doing this, only an upside of making sure that we've got everything that we have taken out of the burette accounted for in the conical flask as well. Okay, and then finally, suggest one reason why repeating a titration makes the value of the average titer more reliable. So accuracy is about getting a value close to what it should be. So for example, if we're doing a titration between HCl and NaOH, which react in a 1-to-1 ratio, and we had the same concentrations of both the acid and the alkali, then we should use the same volumes. So if you put 25 in the conical flask, then you should be adding 25 from the burette. If we got close to 25 as our volume from the burette, then that would mean we've done an accurate titration. When we're thinking about our reliability, it's about the repeatability, if you will. Can we do that same accurate titration many times? Now, of course, there may be certain things that go wrong with any one particular titration. So only doing one is a bad idea because you might get an anomalous result. And that's not just true of titrations, that's true of every single practical. There could be something that goes wrong, and if you only do 1 or 2 run-throughs, then the anomaly will be counted, whereas we should always discard the anomalies when we're doing calculations. So by repeating the titration, we are then able to ignore any anomalous results. We can also then think about this idea of concordancy, which is where the titers differ by no more than plus or minus 0.1 centimetre cubed. And again, if we're only then using the concordant results, then that is going to give us a more accurate titer value. So repeats are always a good idea in any experiment, because it means that any anomalous results will be or can be identified and then obviously removed. So the results from the titration may be anomalous, whereas repeats would enable us to spot any anomalies and ignore them. For our calculations using only the concordant results. And I'll just make a little note there that with concordant results we're looking for plus or minus 0.10 centimetres cubed. Okay, now I might be wrong here, but I would imagine when you were doing this required practical, probably quite early on in year 12, you were probably thinking more about making sure that you were following the method correctly, that you were achieving all those practical competencies. And I know certainly from my own point of view, doing a practical for the first time, I was never really switched on to thinking, oh, why am I doing this? What's the purpose of this? What's the purpose of that? Particularly when there's time pressure as well. So I don't know how many of you will have ever thought about any of these things or any of the other things they might ask in terms of the issue of leaving the funnel in the burette at the top after you've filled up the burette, once you've started your titration, the whole idea of rinsing the burette and the pipette not with water but the solutions you're going to fill them with, air bubbles being inside the burette and the problems that they might cause, and more. It's totally understandable if you've never thought of those things, and you certainly weren't thinking about them during the practical, but as we can see, these are the sorts of things that we need to be aware of now. So if you think required practicals are something that you need some help with, let me know. I have got my required practical summary sheets that are available for purchase, whereby there is one A3 sheet per required practical, or 2 if it's kind of split into 2 parts, like RP1, make a standard solution and then do a titration with it, whereby I've talked about the what and the why and the apparatus and the calculations, which may just help. But yeah, anything I can do, guys, please don't hesitate to get in touch. Hopefully that's been useful to see some of the things that we need to know about titrations. And thank you so much for watching. Take care.